find at least one rational root for each polynomial. So we're going to find one solution that works. So that means we'll generate the list of possible solutions, then plug them in and see if we find a solution. And look, what does it tell us here in bold? When we plug the x value in, if it equals 0, then that x is a solution. That's what we're looking for. If we get a 0, we found a solution. If it's not a 0, then it's not a solution. Okay, so take a look at this equation here. And hopefully this looks kind of familiar. This is actually the exact same equation which we were working with right here. And so we've already found all of the possible solutions, right? This equation here for number 4, same one. These were our p-values. The only q value was a 1. So when we did p divided by q, we just got those same p-values back. And these here are the possible solutions. So these numbers could be positive, could be negative. All right, so let's see. Let me just bring that list over here. All right, so look, those are possible solutions to this equation. And let's actually make this an equation here, right? Equals 0. We want to figure out which of these numbers, when we plug it in for x, do we actually get a 0. So this is what it's going to look like. Let's copy down the equation, replace every x with a set of parentheses. Plus 24 equals 0. So we're going to plug in a number. Now you can pick anyone to start. I guess I'll just start with, I'll pick positive 1. Okay, positive 1. Let's do that. Plug that in, positive 1. And this is what I want to know. Is it actually equal to 0? Now, let's see here. When I plug that in, I'm going to use my calculator. Actually, I'm using Desmos. I don't think you're going to be able to see it, but you can plug this in on Desmos calculator or just on your handheld calculator. Let's see, what do we get? When I plug in a positive 1, okay, I'm getting a 9. I'm not getting a 0. So you know what? That means positive 1 is no good, okay? Maybe I don't want to cross that off the list until I check negative 1. Let's do this. All right, positive 1 didn't work. Let's try negative 1. So now plug this in on your calculator. When I plug in a negative 1, I get 23. So again, not a 0. So 1 doesn't work. Neither positive 1 nor negative 1. Okay, so we could just keep going down the list. You don't necessarily have to go in any particular order here. You could go straight to 24. It doesn't really matter. I'll go in order. So let's see. I'll try positive 2. So when I plug in positive 2, I get a negative 16. So positive 2 also, right? If you plug in a positive 2 here, that doesn't work. That's no good. Let's try negative 2. And when I plug in a negative 2, oh, it looks like we found a winner. When I plug in negative 2, the function evaluates to a 0. So you should see 0 on your calculator. If you're doing it in Desmos, type it in on Desmos, you get a 0. And that's how we know that we found a solution. So actually negative 2 does indeed work. So this is what we've got here. X equals negative 2 is a solution. Let's see. Find at least one rational root for each polynomial. Okay, we've done that. We found one rational solution. Now, of course, we know that since this is a degree 3 equation, there's going to be a total of 3 solutions. This is only one of them. To get the other 2, you could keep checking on the list, and maybe the other 2 are on there. It's also possible that the other 2 solutions are not on the list because they could be irrational numbers. They could even actually possibly be imaginary numbers, which we haven't seen those as solutions to a degree 3 equation yet. But if you remember when we did our quadratic equations, imaginary numbers or complex numbers are a possible solution. So it's also possible we have complex solutions here. So what you want to do here to be sure that you can find the two remaining solutions is you do synthetic division using a -2 and using these coefficients. Okay, here, I'll just set it up for you. I'm not going to solve it because this problem doesn't ask to solve and find all solutions. I'm kind of doing some extra here, but just so you see, this -2 goes here. Don't change the sign because this is a solution. Use our coefficients from here. So that's going to be a 1, -8, -8, 24. Okay, and then you could do this, and the quadratic down here, you could solve that to get the last two remaining solutions. But we're done with this. We did more on this one than we actually were asked to do. So we're done with this one.